Visualize an area where the stars seem to disappear, glittering as galaxies choose to call it quits. What hidden mysteries might lie there? Are we on the verge of unraveling the greatest riddle of the universe? Or is this just the beginning of an entirely new chapter in our cosmic journey? At least that appears to be what the James Webb Telescope suggests. It has discovered the end of space. Indeed, you heard correctly. Space itself may not be as infinite as we once thought. But wait a minute. How can there be an end to space? Wasn't it meant to continue forever? All right, let's examine what's truly happening. When I learned of this information for the first time, I was so excited to explore one of the many mysteries that the James Webb Telescope has been uncovering. It's flipping our comprehension of the universe on its head. After just 12 hours of observation, this marvel revealed things that left us wide-eyed and scratching our heads. Now, let's imagine the universe is indeed vast. Let your thoughts wander and picture reaching as far as your intellect will allow, to the very edge of space. Let's investigate immediately how far the James Webb Telescope can truly see what's out there. Imagine a very fast spacecraft as we now proceed beyond the edge of our solar system, moving past planets like Uranus, Mars, Jupiter, Saturn, and Neptune. We have discussed 100 astronomical units, and we are now at the border of the heliosphere. As we enter interstellar space, after Voyager 1 and 2 departed, we ascend toward the Oort cloud, a wall of 200,000 astronomical units filled with asteroids. It's sparse away from Earth, and we navigate the asteroids with ease, scurrying by as darkness envelopes us. As we approach the edge of the stars and planets, we find our galaxy in a matter of minutes, feeling the interstellar wind as mere specks in other galaxies. Calculating our path, we become aware that the universe has a finite amount of space. 10 billion light-years away from the border, perhaps alternative worlds exist where there is a supervoid, evidence of a collision with another universe. But how can we access these black holes in other universes? Perhaps the secret lies within their mystery, bending time and space in ways we have yet to understand. Scientists even suggest that there may be white holes, which are the opposites of black holes. The theory posits that these could result in alternate realities. Recall the extraordinary energy spike of 2006, possibly a young white hole that was nearly instantly destroyed. Now, let's discuss the direction of the Andromeda Galaxy. Don't panic. Our trajectory won't lead to a crash the following day, but when it does, it could be fascinating. We might witness stars colliding or the solar system being flung into a shadowy area, like a tennis ball swiftly freed from a rope. Ahead lies the merging of galaxies and dark centers that initiate a cosmic dance. They ultimately unite to form a supermassive black hole, spewing forth energy and creating a visible, active galactic nucleus. After millions of light-years, we encounter the Great Wall of Hercules Corona, a massive superstructure with a width of 10 billion light-years. Don't overlook the enormous quasar group spread over 4 billion light-years, boasting a mass 6 billion times greater than the Sun. Next comes the observable universe, which contains more than 500 billion galaxies, each with countless stars. However, there is also something known as the supervoid, a billion light-year wide cold spot. Some believe it results from two bubbles in the universe colliding, ripping away material. Now, imagine the cosmos as a massive bubble. There may be wormholes, endless bubbles, or portals within black holes that allow brief crossovers between these worlds. Picture a piece of paper being folded to join 2 points without traversing the entire sheet. That's the concept being discussed. Black holes colliding might allow for one to survive if it's large enough, evading the terrifying spaghettification. Does anyone know how to survive a tumble? This idea could place you in a new situation. However, a universe with distinct physics remains just a wild theory for now. Picture yourself on a starry night, looking up at the stars. It might seem like they're dispersed equally, but that appears to be misleading. In reality, each of those stars is part of something enormous, a vast cosmic web linking all the universe's galaxies. Using the James Webb Space Telescope, astronomers have recently discovered what could be the most ancient thread in the cosmic web. Now, allow me to dissect it for you. A document released in the Journal of Astrophysical Research Letters reveals what scientists are up to. They utilized data from this incredible discovery to unveil a massive tendril composed of 10 closely spaced galaxy clusters spanning about 3 million light-years. Xiao Fan, a Chinese astronomer at Arizona University and a member of the study team, expressed his surprise. "I was taken aback by how long and thin this filament is. While he anticipated finding something, he was wrong about the structure. Discovering such a long, noticeably thin structure is akin to uncovering a buried historic treasure in the cosmos. This ancient gas filament is only 830 million years old, dating back to the early stages of the universe. Can you guess what's supporting this enormous structure? Imagine a really large black hole, specifically a quasar, which is incredibly luminous. This celestial object serves as the backbone of this cosmic structure. The team responsible for this astounding finding is part of the SPHERE project. SPHERE represents a spectroscopic investigation of skewed halos, a fancy term for the reionization era, aimed at determining how the earliest black holes impacted the development of galaxies. Guess what caught their attention? An old filament, one of the first 25 galaxies in the universe, a quasar. Astrophysicist Fage Wang from Arizona University is quite enthusiastic about this. He stated, "It feels like we've found a cosmic treasure map disclosing details about the beginning of the cosmos. Now, things start to get fascinating." Scholars believe that black holes played a vital role in forming this structure. Imagine black holes acting in the cosmic web, similar to magnets drawing materials together with their mass. However, they also sporadically toss objects away with what is referred to as cosmic winds. Gravity serves as the binding agent that connects dust and stars, even as cosmic winds attempt to drag them across the universe's vastness. So, what's the fate of this ancient filament? Researchers have an intriguing theory, suggesting that eventually, this cosmic thread will compact into a group of galaxies, similar to the Coma cluster, which is about 330 million light-years away from us. It's like observing the universe develop and create its own complex masterpiece over millions of years. After the Webb telescope focused on a section of the sky, it could see far more galaxies and more light than anticipated. Not merely some galaxies, but large, bright ones. Today, scientists are rubbing their eyes and rising to meet several explanations for this cosmic enigma. Allow me to explain these options, which resemble forks in the road, each raising fresh questions. The first choice posits that galaxies and stars formed in distinct ways, evolving more effectively in the early universe. This presents a dimly lit area devoid of numerous stars and galaxies, making it surprising how rapidly they formed. But this does not require a complete revision of what is already known. The second option suggests that the luminosity we observe may not come from stars, but from really large black holes. Yes, you heard correctly. Instead of viewing galaxies illuminated by stars, we could be observing galaxies illuminated by these strange black holes. If they are real, it questions the information we believe to be true. How many of these entities were present in the early universe? The third option, an improbable scenario, is that our understanding of the universe's formula is not yet complete. It may sound extreme, but it could alter our comprehension of all options. Additionally, there is the wild card option. There may be an unidentified component in the cosmos that we've barely considered. Why does all of this matter? It's about locating our position in the universe and realizing the narrative of our journey thus far. If this story is lacking something crucial, it resembles trying to solve a problem without all the components. The more we explore this enigma, the more questions arise. New research from the James Webb Telescope suggests we may have made a mistake in our understanding of the universe. Scientists have asserted that the telescope saw glimmers of objects just 120 million years after the Big Bang. This even questions the fundamental basis of the conventional cosmological model, suggesting that the universe may not be as old as previously believed. According to Einstein, there is an infinite age of the universe, but it appears that he fell short of our understanding. Our intuition has been deceiving us, and we're beginning to believe that we lack a clear understanding of what the James Webb Telescope is attempting to see as far into space as possible. Currently, we call it approximately 46.5 billion light-years away, which is the Hubble sphere or radius. Guess which galaxy is the furthest ever identified using the telescope? Only 450 million years after the Big Bang, it lies within this Hubble sphere. Our cosmos now resembles a balloon that is continuously expanding, growing faster in its reach beyond the universe's Hubble sphere, which is expanding out more quickly than light. However, the Hubble sphere can't continue to expand indefinitely. There is a cosmic horizon limit that is never-ending, a fanciful term for the cosmos that can be observed. Visualize a massive, fictitious shell 93 billion light-years wide. That's our surroundings, restricting how far away anything is that we can see. Beyond that, even with the most advanced telescopes, that light simply hasn't reached us yet. However, how vast is the cosmos as a whole? We don't exist outside of our cosmic shell. Some scientists believe that there are opposing theories, and sometimes mathematics even surpasses us. Some claim it might be endless, while others toss numbers around as if they were the universe, suggesting it is 122 times larger than what is visible. However, the universe's matter distribution and the even distribution of temperature in the cosmic microwave background radiation imply that our cosmos may indeed be infinite. Yes, you heard correctly. It's endlessly mind-blowing when we look out into the grandeur of the cosmos. We're not merely observing distant galaxies. We're essentially looking back at those galaxies as they were when the Hubble Space Telescope captured them. They're not moments frozen in time. They resemble cosmic fossils, remnants from billions of years ago during the dawn of the universe. It's like owning a time machine, yet instead of traveling, we're simply searching very far back in time. Based on our cosmic model, the universe, which existed roughly 14 billion years ago, was compressed into a tiny point known as the singularity. That's the standard narrative of a limited cosmos. But if the cosmos appears limitless, then the Big Bang wasn't a confined event. It was an incident that occurred everywhere at the same time. The first galaxies did not form in a specific area of space. They were the grand opening act of the universe, appearing everywhere, even beyond our field of vision. But what truly matters is what set everything in motion. What or who initiated the Big Bang? At first, Einstein opposed the concept of a Big Bang, favoring a stable state, one where the universe had always been static. However, equations have a powerful way of changing one's mind. He ultimately embraced the idea of the Big Bang. Yet some individuals, as narrated by our helpful scientific narrator, view the singularity in this cosmic story not as the beginning but as a universal birth certificate that remains unknown. When we believed we understood the universe's biography, the James Webb Telescope arrived and completely blew us away. It recently discovered the F200 DB45, a galaxy with the potential to alter our understanding of cosmic history. This galaxy is so far away that if verified, it would put our comfortable narrative of a 13.8 billion-year-old universe to the test. The Webb telescope has currently discovered galaxies that, according to the current understanding, shouldn't exist, enormous galaxies that emerged just a million years after the Big Bang. This cosmic speedrun exceeds the timeline established by our current knowledge. Even more astounding is that early black holes were detected only 70 million years after the Big Bang. The merging of black holes may provide an explanation for these cosmic vacuum cleaners reaching their toddler years. These revelations are causing cosmological disorder within the realm of cosmology. Perhaps the universe is older than we think. Perhaps it has always existed without a beginning. First of all, consider the possibility that our universe resembles that beloved children's book that has always been without a beginning page, simply emerging through various sections as we look farther into space. The notion of an endless universe makes sense even if it appears perplexing. Why not have an infinite age given its limitless size? Perhaps the Big Bang was merely a passing event, a twist that is not the first seen but significant nonetheless. Further study is required. This timeless nature of the universe raises questions about whether the current scientific paradigm can explain the complex dance of happenings during the Big Bang. There could be approximately 2 trillion galaxies, but astronomers are struggling to comprehend the extent of the cosmos that exists beyond their field of vision. According to astronomer Virginia Trimble from the University of California, the universe has always been slightly larger than what is visible. It appears as though the universe is hiding, and we are making a valiant effort to determine its hiding place. John Mather, a cosmologist and Nobel Prize winner, notes that NASA has explored as far as our imagination can carry us. At the very edge, we can just make out the remnants of the Big Bang. Yet this is significant, and the story doesn't end here. The cosmos continues, and we may never know where their quest will take them. Cosmologists have turned to fragments from classical Greek mathematicians, attempting to determine the shape of the universe. To crack this code, consider it as determining if the cosmos is massive or flat. The concept of a saddle-shaped universe has few fans, but a pleasant spherical universe is appealing. Einstein referred to this paradigm as a bounded but finite cosmos. However, telescopes studying cosmic rays in the late 1980s revealed a shocking revelation. It appears that space has no curvature. It is completely flat, a pancake, as John Ma describes it. Imagine an infinite piece of paper so that you could journey endlessly in every direction, and the universe would appear essentially the same. Just flat galaxies on galaxies. This idea is amazing to most astronomers as it aligns with what they see and the theories they conjure up. Yet, in contrast, a flat universe could also be spherical, limitless, or perhaps not. There's no definitive method to differentiate. Virginia Trimble aptly summarizes this by asking if anyone can explore to see if the universe is endless. It's like attempting to determine whether a pizza is infinite or whether you'll eventually hit a rough, crusty edge. You understand how we sometimes ponder the universe's edge and what would happen if we tried to reach it. It's an exceptionally perplexing concept, considering that the universe is theoretically endless. But let's break it down. People often say the universe encompasses all of space and time, but does it truly define our reality? What if we ventured beyond the edge of our universe? Would it be entirely distinct from our current understanding? These are the inquiries scientists are grappling with. But what if the cosmos isn't perfectly flat? What if there's a curvature that we haven't accurately quantified? If the curve is positively curved, the universe might represent the exterior of a hypersphere, a 3D surface of a 4D sphere. If we had a warp ship in this scenario, we might ultimately journey around this hypersphere's curvature and return to where we began. However, these concepts presumptively utilize a basic implementation of general relativity and Einstein's equations. They're fascinating, yet they're not the end-all. Lastly, a few theories propose that our cosmos is essentially a gradually expanding bubble within a never-ending inflation scenario. Bubble universes and multiverses could be limited in scope and have a genuine edge. Conversely, do the principles of physics shift? Perhaps they do not. Astronomers are carefully looking for a theory's lifeline, seeking a model that can indirectly demonstrate whether the universe is infinite or not. When scientists previously hypothesized the existence of particles like the Higgs boson, they felt a sense of certainty that their model would be confirmed, and as it happened, they were correct. Virginia Trimble asserts that scientists must provide a clear explanation of everything observed thus far, as it forecasts something to be accurate. This expectation that a clever idea will lead us to the right path assists us in unraveling the cosmic enigma that has perplexed us since Galileo first pointed his telescope skyward. Now for the thrilling part. You're not just an observer. You can participate in the investigation and share your thoughts regarding these cosmic discoveries in the comments below. Do you believe there's a hidden meaning in those far-off lights? Or is the cosmos engaged in a game of hide and seek with us? If space fascinates you, remember to ring the like button, subscribe, and hit the notification bell that beats at the speed of light. We'll provide you with updates on the latest findings and delve even further into the universe's mysteries. Until then, continue to wonder, continue to explore, and who knows? Perhaps you will be the one to unlock the universe's code.